Well, hello there. Sion Batson here from Sion Batson Tutoring, and in this video, I will be teaching you how to use the product rule for exponents, a very important concept for 8th grade students, high school students, GED students, and college students. So let's go. Now, this exercise is out of my pre-algebra workbook. You can master essential algebra skills, a simple guide. Now, this book is an excellent resource for homeschooling, virtual learning, extra practice at home, homework help, and state test prep. It is filled with very simple and easy to follow notes and explanations, step-by-step examples, guided examples, and almost 300 practice problems and answers. So if you have an 8th grader, a high schooler, or even if you are getting ready to take the GED exam, I would highly recommend that you get a copy. You can get your copy from Amazon or from my website, www.sbatsonacademy.com. Now, to our exercise. The product rule for exponents states, when multiplying terms that have the same base, we can add the exponents. That's it. A very simple rule, yes? When multiplying terms that have the same base, we can add the exponents. How are you feeling? Perfect. Now, here's an extra note to keep in mind. If the terms have coefficients, we will multiply the coefficients, then add the exponents, yes? Keep that in mind. Now, before we go to our first example, I want to review two quick things with you. One, let's talk about terms that are in exponent form. A term in exponent form can have a base and an exponent, or it can have a coefficient, a base, and an exponent. Yes? All right. And secondly, let us talk about the lonely variable. Whenever you see a variable by itself, just the bare letter, always remember there are two things hiding in the shadows. One, its coefficient will always be 1. And very important as well, its exponent is always 1. Never forget that. Yes? How are you feeling so far? Perfect! Now, let's get the party going. For example 1, we have y to the second power times y to the 5th power. Now, since we are multiplying these terms, and because they have the same base, our base for the first term here is y, and the base for the second term is y as well. Since both terms have the same base, and because we are multiplying these two terms, we can add their exponents. Look what happened. The base stays the same. You do not touch the base. The base will always remain the same. And we add the exponents. 2 plus 5. Yes? So our answer here will be y. 2 plus 5 is 7. So y to the second power times y to the 5th power is equal to y to the 7th power. How is that? It's very simple. It's very exciting. It's very straightforward. How are you feeling? Super, super. All right. Now, before I continue, if you are new to my YouTube channel, welcome, welcome, welcome. And thank you for joining us. Now, please click on the subscribe button and turn your notifications on so that you can be notified every time I post a fun, exciting, and straightforward math tutorial. Yes? Perfect! Now, let's keep the party going. All right. Let's say we have 2 to the 4th power times 2 to the 7th power. Yes? Again, we can use the product rule. Why? Because we are multiplying terms that have exponents. Yes? Also, not only do they have exponents, but they have the same base. So because they have the same base, we can add the exponents. So remember, the base stays the same. And we're going to add the 4 and the 7. And this will give us 2 to the 4 plus 7 is 11. So 2 to the 4th power times 2 to the 7th power is equal to 2 to the 11th power. It's very simple. It's very straightforward. How are you feeling? Give me a high five. The energy is going to be real in this video right here because I am so pumped right now. Yes. We're having a good time, right? We're having a good time. All right. Here's an interesting one here. Let's say we have b to the 8th power times b. Very interesting one here. Now, the first thing I want you to see is that we have a lonely variable. It's lonely because its exponent is hiding. Remember what we said. Whenever you see a lonely variable, the exponent is always 1. So the very first thing we can do here is put a 1 there. I always put that 1 first before I begin to multiply, just to remind myself that that 1 is hiding in the shadows, yes? Now, let's continue. Again, we are multiplying terms that have exponents and the same base. Therefore, we can use the product rule. The base stays the same, never touch the bases. And we will add our exponents. Yes? So we will get b, 8 plus 1 is 9. So b to the 8th power times b, or b to the 8th power times b to the 1st power is equal to b to the 9th power. How are you feeling right now? Come on. Listen, this is a very exciting concept here. Yes? Very exciting. All right. Let's keep our party going. Come on. Let's say we have 5 to the 2nd power, to the negative 2nd power, or to the negative 2 power, times 5 to the 4th power. Interesting stuff. Again, what are we doing here? We are multiplying terms that have the same base and exponents. So since our terms have the same base, we can add the exponents. That's what the product rule states. So again, remember, the bases stay the same. You never add or multiply the bases. The base is 5, so the 5 stays. Then we add our exponents. Negative 2 plus 4. And what is negative 2 plus 4? Remember, when adding and subtracting integers, you must respect both signs. It's very tempting to add because there is an addition sign in the middle here. But we cannot ignore this negative sign. We must respect both signs. When the signs are different, like this example, this sign is negative, this sign is positive. When the signs are different, we subtract. Yes? So our base stays the same. If we subtract 4 and 2, we will get 2. And after subtracting, we always do what? Keep the sign that's in front of the bigger number, or the bigger integer. The bigger integer here is 4, and the sign in front of the 4 is positive. So we can say 5 to the positive 2, or 5 to the 2nd power. How are you feeling? Now, if you need to review how to add and subtract integers, I did a very detailed video for you, yes, that teaches you step by step how to add and subtract integers. If you need to review, watch that video, master the skill, and come back and join us. How are you feeling so far though? Super! Super! Can you feel my energy right now? Can you feel my energy? How are you feeling? All right, let's do a couple more here. Let's say we have c to the 7th power, c to the 7th power times c to the negative 5. Ooh! These negative integers really make things spicy. Yes, spicy. Now again, we are multiplying terms that have exponents and the same base. Therefore, we can use the product rule. Yes, and the product rule says we can add their exponents. So the base stays the same. The base is c. We don't touch that c. And we will add 7 plus a negative 5. Look at this one right here. Now again, when adding and subtracting integers, if two signs are next to each other, we can combine them. Very good. So we combine this positive and negative sign. And if we combine a positive and a negative, we will get a negative. Very good. So this really looks like c to the 7 minus 5. Yes? Again, if you need to review how to add and subtract integers, I did 2 very simple and easy to follow videos for you. Go watch them, master the skill, then come back. Because once you're dealing with the exponents, you will run into integers. Yes? All right, let's continue. So after we combine our signs, we have c to the 7 minus 5. And this will give us what? C to the 2nd power. How are you feeling right now, my friends? All right. Pumped up, pumped up, pumped up. Good stuff, good stuff, good stuff. All right. Now, I have some here for you. I have some for you guys. I have problems for you guys, okay? I have some very nice problems for you guys here. Now, you guys will get a chance to shine. I know you guys are eager, waiting to try one. You guys know I will give you all a chance to shine. Yes? All right. So here we have g to the 7th power times g to the 2nd power times g. So we have 3 terms here. Now, the very first thing I want you to see is that we have a lonely variable. And whenever we have a lonely variable, we know that its exponent is always 1. I'm going to put that 1 back first, just so we do not forget. Always put the 1 first before you begin adding. Yes? Let's go. Since we have 3 terms, we're going to simplify things and work with 2 terms at a time. Yes? We want to make life easy here. Yes? So we have g to the 7th power times g to the 2nd power. Yes? Since we are multiplying terms that have the same base and exponents, they have the same base and they have exponents as well. Yes? We can add their exponents. So we get g to the 7 plus 2, which is equal to g to the 9th power. Yes? And don't forget our g at the top, the last g here, g to the 1st power. Again, we are multiplying terms that have the same base. Therefore, we can add the exponents. Yes? The base stays the same. And 9 plus 1, we add the exponents. We get g to the 10th power. How is that? Now, I know some of you are saying, Sion, why do I need to break it up and do 2 at a time? Life is easier. You are less likely to make a mistake. But if you are a genius and you feel, well, I don't have to do all of that, Sion, that's fine. You can, since all the terms have the same base, put back your base and add. 7 plus 2 plus 1 that will still give us g to the 10th power. How are you guys feeling? All right. It's a very simple concept. It's a very straightforward concept. Yes? All right. Now, let us keep things going here. Let's keep things going here. Let's say we have, let's come here now. Do some fancy stuff here. I have to give you guys some with coefficients. We having a good time. Spicy stuff here, right? Spicy. Put some hot sauce and some black pepper and some chili peppers in the pot. Let's get the spiciness going. Here, we are multiplying terms that have the same base, yes? However, we have what? Coefficients. Very good. Remember, the extra note I give you, whenever there are coefficients, we will multiply the coefficients first, then add the exponents once the bases are the same. Yes? Don't forget that. You don't make the mistake of trying to add the coefficients. You only add the exponents when the bases are the same. But once they are coefficients, you have to multiply them because it's a multiplication problem. Yes? So we will multiply our coefficients first. 4 times 2 will give us 8. So we have our 8. Yes? And now we deal with our variable or the base, m. 3 plus 2. Add the exponents. Yes? So this will give us 8m to the 5th power. How is that? It's very simple stuff. It's very exciting stuff. What's extremely important is that you stick to the rules. I give you all the rules. I give you the rule. I give you the note, and I give you some extra notes. So we have everything covered. All right. Let's try at least 2 more. We have time. Let's see. I don't want to skip anything. That's why I am taking my time here to get as much done as possible, okay? All right. Again, do you see anything interesting here? Yes, we have a lonely variable. So the r is lonely, and remember, whenever you see just the variable, its exponent will always be 1. So always put that 1 first before you begin multiplying or adding. Yes? All right. Our terms have coefficients. So we will multiply the coefficients first. Let's go. The first coefficient is 6. The second one is 5. 6 times 5 is 30. And since we have the same base here, we can add the exponents. So we have 30r to the 7th power. Make my 7 better. How are you guys feeling, man? Tell me you're feeling pumped. You're feeling great. I have so many examples here that I want to work. All right, let's see what we have here. Woo! I see a very spicy one here. Whoa! Look at this one here. I see all the spiciness here. Oh my goodness! I hope you guys are ready for the heat that I'm about to drop on you all right now. I am about to give you guys the real deal here. Woo! 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 Hot! All right, we have a couple of things going on here, yes? We have coefficients, and we have 2 sets of variables. Don't worry, don't worry. We will break it down and go step by step. First, we have coefficients, yes? We have 3 and 7. So let's deal with the coefficients first, yeah? We can do 3 times 7, and that is 21. Now, let's deal with our variables here. We have a u here, and we have u here as well. So we will deal with the u's first, yes? Since we have a u, we can make this, we can do the u. Since we multiply, we're going to add the exponents, yes? So u to the fourth times u to the second. This will give us u to the 4 plus 2, which is u to the 6th. Yes? Then we have what? V's. Don't overcomplicate it and try to work it all at one time. Break it down. I did my coefficients first. I work with the first base or the first variable first. Then I go with the second variable here, which is, or the second base, which is v. I have v to the 5 times v to the third. Again, since my bases are the same and I'm multiplying, I can add the exponents. V to the 8. Break it up. Don't complicate things. So we have 21 first. Then we have u to the 6. Then we have v to the 8. Take your time, break it up, go step by step. This is fun stuff. I'm telling you right now, if you're in 8th grade, very important concept. High school, very important concept. College, very important concept. If you're taking the GED exam, very important concept. If you're taking the SATs, if you're taking the GRE, I can remember seeing these when I took my GRE. I saw these. All right, I'm going to work one more. Then I'll give you guys a chance to shine. I know, right? This is an extra long lesson because I'm trying to cover a lot here. All right, let's do. All right, 7v to the negative 10 times 2v to the negative 3. Ooh, spicy stuff here. Again, our terms have the same base, but they have coefficients. So we are going to multiply the coefficients first. 7 times 2 will give me 14. So I take care of my coefficients first. Since my terms have the same base, I can add their exponents. So I have 10 v to the negative 10 times v to the negative 3. So this will give me v to the negative 10 plus negative 3. Right? We have to add the exponents when we are multiplying terms that have the same base. Yes? Again, when adding and subtracting integers, whenever two signs are next to each other, we can combine them. If we combine a positive sign and a negative sign, we will get a negative sign. Yes? So we will get v to the negative 10 minus 3. Because these two signs became a negative sign. Now we can continue. Negative 10 minus 3 will give us negative 13. When we are adding or subtracting terms that have the same sign in front of the integers, yes? Once the integers have the same signs, we add. If we add 10 and 3, we get 13. Yes? And after adding or subtracting, we always keep the sign that's in front of the bigger integer. So here we get v to the negative 13. How is that? How are you feeling? Now, note, my friends, note, we aren't finished here because we have a negative exponent in our answer. And we never want to leave a negative exponent in our answer. Yes? Whenever there is a negative exponent in our answer, we want to change it to positive. To change a negative exponent to a positive exponent, remember the rule. We will simply move the negative exponent and the term attached to the negative exponent. Yes? If you need to review again how to change a negative exponent to a positive exponent, I did a very detailed video that teaches you how to change a negative exponent to a positive exponent. Go watch that video. Master the skill. Yes? So we want to make this negative 13 positive. So again, quickly remember, 14v to the negative 13 is the same as 14 times v to the negative 13. So this negative 13 is only attached to the v. So to make this negative 13 positive, we will move the v and the negative 13 down to the denominator. So we get here, after the move, see that? Our 13 is now positive. Once you make the move, the exponent, the negative exponent becomes positive. How are you feeling? Super! Very good. Now, I have to give you guys a chance to shine. I know it's a long video. It's a long lesson, but I wanted to cover a lot. So now, I'm going to give you guys a chance to shine. Let's see what we have. Let's do... So you're going to pause the video, yes? Give it a try, then you're going to come back and let's see if we get the same answer. Now, if needed, like always, you can go back, watch the previous examples, then come back and try this one, yes? All right, give it a try. Stick to the rule. All right. Now, welcome back. Welcome back. I believe and I know that you guys got the correct answer, but still, let's work it to make sure. Again, we are multiplying terms that have exponents and the same base as well. So since the bases are the same, we can add the exponents. The y stays, never touch the base, we never touch the base. And we add the exponents, negative 8 plus 12. Yes, that will give us y to the positive 4. Remember, when adding and subtracting integers, when the signs in front of the integers are different, we are going to subtract. If we subtract 12 and 8, we will get 4. After subtracting, we do what? Always keep the sign that's in front of the bigger integer. Very good. Very good. All right. Let's do one more. Let's do one more here and we are out of here. Yes? I have to give you guys some spices or some heat before I leave. I'm leaving you guys with some heat here. So again, I want you to pause the video. Give the problem a try, then come back and let's see if we get the same answer. I believe in you. You got this. Let's go. Come on. All right. Welcome back. Welcome back. How are you feeling? How are you feeling? How are you feeling? Good? All right. Let's go. So again, our two terms here, they have coefficients and they have two sets of bases. So we'll go one step at a time, yes? We'll first do the coefficients. We'll do 10 times 8, that is 80. Now we go to the variables. Now, do you notice anything special here? Yes, we have a lonely variable. So we're going to put the 1 to remind us that this x has an exponent of 1. Now we will work with one set of variables at a time. Let's do the x's first. So we have x to the first power times x to the fifth power. Since the bases are the same, we can add the exponents. Yes? And then we go to the y. Y to the third times y to the sixth. Since the bases are the same, we can add the exponents. So it's always simple and easier to go one step at a time, work with your coefficients, then work with one group of variable at a time, yes? So after we're done, we have 80 x to the 6th power, y to the 9th power. How was that? Very good job. I know you guys got the correct answer. In case you forgot to put that 1, I hope none of you forgot to put that 1, yes? But give yourselves a big tap on the shoulder for sticking out with me, yes? I really hope you guys enjoyed my video. I really hope you guys will find it helpful and useful. Until next time, enjoy your math practice and your math homework. See you.